Hello everyone, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In my weekly sessions on ISI and CMI preparation, I have been solving previous year papers for last 3 weeks. Today I will be solving this CMI 2018 Part B. Last week I discussed 2018 Part A in which 10 questions were there. That Part A was easy. I will say not difficult, slightly towards easier. Today, let us see how these questions are. My overall assessment is that this paper was little difficult, or you can say average plus. So let us start with this first question, which says a natural number k is called stable if there exist k distinct natural numbers a1, a2, ak with each ai greater than 1 such that sum of reciprocals of all these integers is equal to 1. We have to prove that if k is stable, then k plus 1 is also stable. Using this or otherwise, find all stable numbers. So let us first check for k equal to 1. I think if k is 1, then we will be taking only one number, that is 1 a1. So 1 upon a1 should be 1. But because of this condition that a1 has to be greater than 1, I think this is not possible. So k equal to 1 cannot be a stable number. Now coming to k equal to 2. So then we have to have two numbers 1 upon a1 and a2, so that 1 upon a1 plus 1 upon a2 is equal to 1. But because they both are distinct and they are greater than 1. So here a1, a2 both will be greater than or equal to 2. But because they are distinct, one of them has to be 3 or more. So if you take the sum of their reciprocal, it cannot become equal to 1. It could have become 1 if they both were 2, 2. So 1 by 2 plus 1 by 2 equal to 1. But if you have to satisfy this condition that they are distinct, then a2 will be at least 3. So the sum cannot be 1. In fact, if we find this a1 plus a2, the maximum sum of these two, it will be less than or equal to 1 by 2 plus 1 by 3, which is 5 by 6. So if k is equal to 2, sum of reciprocal of these two numbers with this condition will be always less than 1. So it cannot be equal to 1. So k equal to 2 is also not a stable number. Now coming to k is equal to 3. Now dear all, if you have done some questions on number system or somewhere else also, you may remember this result that 1 by 2 plus 1 by 3 plus 1 by 6, if you add, they becomes equal to 1. This clearly tells us that k is equal to 3 is a stable number. But if you do not remember this result, then also you can find what three numbers would be. Like if you are having 1 upon a1 plus 1 upon a2 plus 1 upon a3 is equal to 1, then a1, the smallest of them being 3, cannot give you cannot give you this sum equal to 1. Suppose my a1 is greater than a2 and a2 is greater than a3. A3 is the smallest one, and suppose a3 is equal to 3. In that case, you can see that 1 upon 3, 1 upon 3, 1 upon 3 becomes 1. But if a2 is greater than a3, a1 is greater than a2, then this sum will not be equal to 1. So in order this to become equal to 1, we have to have the smallest number, let us say a3, to be equal to 2, because they have to be greater than 1. So a3 has to be 2, then only there is a possibility this becomes equal to 1. And then we will have 1 upon a1 plus 1 upon a2 is equal to 1 minus half, that is 1 by 2. And now using the concept that we did in Diophantine equation by taking LCM, this will be a1 plus a2 into 2 is equal to a1 into a2. Okay, if you solve it, we will get a1 minus 2 into a2 minus 2 is equal to 4. And because a1 a2 are natural numbers, okay, and they are greater than 1, so this product becoming 4 is possible only if this larger number is a1, so this becomes 4 and this becomes 1, and that will be possible only if a1 is 6 and a2 is equal to 3, and hence this is what I was saying in the beginning. So k is equal to 3 is definitely a stable number, and we have found these 1 by 2, 1 by 3, 1 by 6 with some logic also. Okay, now the second part, which says if k is a stable number, then we have to prove that k plus 1 is also stable number. Now to do this thing, let us assume that 1 upon a1, 1 upon a2 and so on, 1 upon ak, they is equal to 1, where we have k as stable number, k as a stable number, so there have to be some a1 a2 up to ak, so that sum of their reciprocal becomes equal to 1. Now if I multiply by 1 by 2 on both sides, 1 by 2 here, 1 by 2 here, okay, what we will get, we will be getting 1 upon 2a1 plus 1 upon 2a2 and so on plus 1 upon 2ak is equal to half. I can write like this. So we will be getting that 1 upon 2 plus 1 upon 2a1 plus 1 upon 2a2 and so on and so on, and in the end it will be 1 upon 2ak, and this is equal to 1. Now because this a1, a2, a3, ak all are distinct, and if I assume that a1 was the smallest, then a2, without loss of generality we can assume that, okay, then this a1 is greater than 1, okay, and hence this 2a1 will be greater than 2, so this 2a1 will be at least 4. So this 2 is different from 2a1, and other numbers 2a2, 2ak and so on, they all will be, you know, distinct numbers such that sum of their reciprocals becomes equal to 1. So already they were k numbers, and I have added 2 also to this thing, so my k plus 1 also becomes a stable number. So k plus 1 is also a stable number. So this completes the solution of this question. I think this first part, that k equal to 1, k equal to 2, k equal to 3, that was easier part. Even this is also easy, but this was something that if this strikes into your mind, then only you will be able to do it. Otherwise, this was not that easy step. Okay, so this was average plus from, in my opinion. Now coming to the B part of this question, it says f is a differentiable function defined on a subset A of real numbers, and we define f star y is equal to maximum of yx minus fx, x belongs to A, whenever the above maximum is defined. Now for function fx is equal to minus ln x, determine the set of points for which f star is defined, and find an expression for f star y involving only y and constant. Okay, so first of all, let us write this f star y equal to maximum of y into x minus plus, this will be ln of x. Okay, and here this x will be from A. In fact, this ln x or minus ln x, its domain is 0 to infinity. So this set will be actually 0 comma infinity, all positive real numbers. Okay, now what we are supposed to do here, please try to understand. For any given value of y, we have to vary all values of x so that we get maximum possible value of yx plus ln y. For given y, okay, for given y, vary x in this 0 comma infinity so that for any given y, this yx plus ln x is maximum. So what we can do, we can take this yx plus ln x as some function, let us say gx, okay, where y was constant, we will be varying this x. So we will try to see when this yx plus ln x will take the maximum value. So here I have taken gx is equal to yx plus ln x. To find at which x it will take maximum value, we will differentiate it, which gives us y plus 1 by x. Please notice, I have differentiated it with respect to x, taking y as a constant. Because for every y, we have to find that what will be the value of x for which we are going to get this expression to be maximum. Okay, now Because x belongs to 0 to infinity, hence 1 upon x will also be positive. So this will be positive throughout if my y is greater than or equal to 0. Even y is 0, then also y plus 1 upon x will be positive because x is from 0 to infinity. But if y is negative, okay, if y is negative, then it can be positive and negative both, and 0 also, I think, and 0 also. If y is negative, then I think we can have all the values. So let me first talk about this. If g dash x is positive for this scenario, then there will be no point of maxima. There will be no point of maxima. In fact, this function in this case gx is strictly increasing. And strictly increasing means as you increase the value of x, for all those cases when y is positive, this yx plus ln x will keep on increasing. We will not be able to get any maximum value of this. This will go up to infinite. And please remember, infinite is not some number whom we can claim to be a maximum. If it is maximum, then it has to be some finite value. Okay. Now, when y is negative, okay, and I put g dash x is equal to 0, we get this x equal to minus 1 upon y. In fact, you can check g double dash x in that case will be minus 1 upon x square, which is negative, which means that x is equal to minus 1 upon y is a point of maxima, is a point of maxima. This means, let me use this space. So whenever this y is negative, okay, so this yx plus ln x will be maximum when x is taken to be minus 1 upon y. And this is what my f star y would be. So I can write this f star y to be equal to, I will put x as minus 1 upon y. So y into x will be minus 1 plus ln of, in place of x I will be writing minus 1 upon y. Okay, so let me use this small space here. It will be minus 1 minus ln of minus y. Don't get confused that ln of negative number, it is not negative because y is negative. Okay, so they have asked us two things. For the function, determine the set of points for which f star is defined. So the set of point for which f star is defined is y belongs to minus infinity to 0. And the expression for f star y involving only y is this thing. Minus 1 minus ln of minus y. So this completes this question. Okay, I think this language was not that easy to comprehend. Otherwise, question was not difficult. Okay, but in the exam pressure, I will rate this as an average plus question. Okay, coming